Hello everyone, it's me, Danny Bannany, and today I'm going to be doing some more math things. I'm going to talk about some square roots. I think last time I may have already said how to calculate square roots, like how to multiply them, like if you were doing 52 squared, you would do 5 times itself, 5 times itself, and then 2 times the cell, which would be 4. And then after that, you just do 5 times 2, 10, add a 0 at the end. Or 5 times 2 is 10, 10 times 2 is 20, so add 200. I think there has to be 1,000 somewhere in there. I think it might go here, but I could be wrong. Oh. 7204. Yeah, see, I already messed up. So what you would do is you put the 4 here, and then you put the 0 at the end there. And then you say 5 times 2 is 10, 10 times 2 is 20, multiply it by 10, add that, and then in the end, you get 274, I should probably make this a little different, 2740, and that's how you get your answer. Okay, so that's how you multiply square roots. If you want to find square roots, it's a little different. What you would do is, let's see, square root examples. Can't spell examples. 144, I guess we can go with. Okay. Let me just type to you the square roots. Try to scroll over a bit, I guess. There we are. Now, what I would say is, like this. Okay. Okay, one squared equals 1. 1 squared equals 1. 2 squared equals 4. 3 squared equals 9. 4 squared equals 16. 5 squared equals 25. Oh wait, 25. 6 squared equals 36. I should make this a little bigger so I can just read it. 7 squared equals 49. 8 squared equals 64. 9 squared equals 81. And 10 squared equals 100. Oh, not 0 squared. 10 squared equals 100. So all you gotta do is remember all that. Now, this is not like the cube roots, okay? It's different. 1, we have 1s ending in 1, and then we also have 1 here, which is 9 and 1. 2, 4, I gotta find the other 4. I think 4 might be on its own. Nope, here's a 64. 64 and 4, which is 2 and 8, which also equals 10. 7 and 3 both end in 9. 6 and 4 end in 6. And 5 is on its own. 5 is anything that ends in 5, its last digit will be a 5 for its square root. Now, 0 is also on its own, like the 100, but that's also fine. So we have 1s, we have no 2s, no 3s, 4s, we have a 5. 6s, no 7s, no 8s, but we do have 9s, because there's only, anyway, back to the point. So something, for example, as 2704, let's write that down. 2704. Now, we already know that the answer for a square root would be 57. But this is how we find it. The number 27, we have to break this up first. The number 27 is right in between 25 and 36. The number that is very close to it without going over it, and then between that is 25, and that's the square root of 5. So, right is the square of 5. So 5 will be our first number here. Now we get 2. 4 perfectly fits into 2 squared. So we just put 2 there, because we have a 4 here that we're using. We can get rid of it as 0. That's usually never important, but sometimes it is. But in this situation it isn't. Now that we have that, our answer would be 52, and we already know that. So that's how you find square roots. Okay. Now, another trick that I would also like to show that I forgot to last time was multiplication. Now, something like, how could I do this? This will take a while, but like, I'll do it pretty quick, hopefully a little quick. 7, 8, 9, 10, 11, 12, 1, put a 0 here, 2, 3, 4, 5, 6, 7, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I can only go to 10, but I can go for 11s and 12s. So for now, I'm just going to make little lines going like that for each number, just so I can quickly make a little chart, I guess you should say. I should have had this prepared and done it first, since it would take the longest, but I don't really think ahead that much when it comes to stuff like this. But I could deal with that. Now, keep going, keep going. Now, just gotta keep going. Oh my gosh, that line was horrible. Not always are the best, but you can cut you some slack for it. If there was any lines in here, actually, check if there's any lines. Because there was, oh my god, there is lines. I am Dumbo. Nope. Don't work like that. Okay. All the way over here. Go back. What I'm going to do is I'm going to go. Nope. This is so dumb. Gets me so on my nerves. Whatever. I'll just back to what I was doing now. I guess I do have to go. I should have tested the line before I did it. But there should be tricks for each of the numbers. Like for 9s, there's a simple trick. Let me just quickly get the graph there. I'll write in the numbers as we go. I do not have a very steady hand. Please forgive me. Oh my goodness. Okay, well, what's sad is this is not even like the main part of all this. 10. Oh my gosh, how did I go up? How does that line better? Whatever. Anyway, then we go like that, that, that. Oh my goodness. You know what? I should have just. I swear I shouldn't have just. What in the world did I do? Okay, thank goodness I thought it was gone. And I would have just started. I should have just used forms, but that'll do for now, I guess. I should just use forms. Or not forms, sheets. Google Sheets. It's a little harder to do that, but I could always just go back if I need to. So. Anyway, now where we are. Now the chart works like this. 1 times 1 is, well, 1s are pretty simple, okay. I will have to do 11s and 12s after, but 1s are pretty simple. It's just the number that you're multiplying 1 by is what the answer will be. So if I'm multiplying 1 by 1, I'll get 1, 2 times 1 is 3, 3 times 1 is 4, 4 times 1 is 4, 5 times 1 is 5, 6 times 1 is 6, 7 times 1 is 8, 8 times 1 is 8, not 9, 9 times 1 is 9, 10 times 1 is 10, 11 times 1 is 11, and 12 times 1 is 12. So that's pretty simple. 2s, it's kind of like 1s, but do it twice. So 2s multiplied by 1 is just 1 plus 1. 2 plus itself 2 again. So 2 plus 2 is 4. 2, 3, 3, 3, or 3 added 2 times, 3 plus 3 is 6. 4 is 8, like 4 times 2 is 8. 5 times 2 is 10. 6 times 2 is 12. 2 times 7 is 14. 8 times 2 is 16. 9 times 2 is 18. 10 times 2 is 20. 11 times 2 is 22. And 12 times 2 is 24. Now, that's for 2s. 3s, you can easily just skip count like 1, 2, and 3. You can just go like, well, 3s, 3 times 1, we already know the 1 trick for that, so we can do 3 times 3 is, 3 times 1 is 1. Oh my gosh. Thinking of 9s and then I messed my, okay, 3 times 1 is 3. 3 times 2 is 6. 3 times, what is it? 3 is 9. 3 times 4 is 12. 3 times 5 is 15. 3 times 6 is 18. That looks like a 9. 3 times 6 is 18. 3 times 7 is 21. 3 times 8 is 24. 3 times, what is it, 9 is 27. I could always just check because I can go back. But 3 times 9 is 27. 3 times 10 is 30. 3 times 11 is 33. There's also a trick for 11s, which is very helpful. 3 times 12 is 36. I think I may have said it for 11s in a different video. 4, again, 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 5, or no, sorry, 4 times 4 is 6. 4 times 5 is, well, 20 of it. 4 times 6 is 24. I can get it, there it is. 4 times, no, whatever. 4 times, 7 is 28. 4 times 8 is 32. 4 times 9 is 36. 4 times 10 is 40. 4 times 11 is 44. And I think I might stop there. 4 times 12 is 48. I can get the rest on its own because some tricks are a little different. So ones I already said. So far we already have everything for ones. Write these ones in. These are pretty simple to get. 7, 8, 9, 10. There should be 11 and 12, but I didn't have enough room for that. So 11 and 12 you could also get. So ones are simple. It's just a number you're multiplying by one, or by itself. So 1 times like 86 would be 86 because it's multiplying it by 1, which if you don't know is just the number plus 0 basically. Anyway, now you take this only when it's with positive numbers. If you're doing like -1 times 1, it will be -1. Like here, let me show you. -1 multiplied by 1 equals, oh wait, equals -1. Way to remember if it will be -1 or 1 is that there's always 2 negatives in an equation like this and only 1 positive. So if I were to do -5 multiplied by 6, it'd be -30. There's 1 and 2 negatives, but only 1 positive. But remember, 2 positives, or I should say, 2 positives equal that's not negative science. Okay, so for example, I think it was 2 negatives at least. Adding 2 negative numbers, by the way, this is right there, is kind of like adding positive numbers, but you just add the negative symbol afterwards. So we already have the ones down. I could cross these out, I guess. That'll be like a cross out, I guess. 2s we have, it's just a number plus itself again. So I'm just going to quickly write these in. 12, 14, right, 7. Then we have, what, 16 there's 16. 18, 20. So we have the 2s down. 3s are just skip counting. 1, 2, 3. 3 times 12 would be 12 plus 12 plus 12. And it also works for 12 this way. You could do how you just count by tens. Like if I were to show you as in a problem over here, 12 plus 12 plus 12. Just add the 10. They say to add from this side. I always add like this. 3 and a 6. That's how you quickly do your answers. Is that it? Okay. Now over here, what are we at? We already did 3s. 15, 18, 21, 24, 27, and 30. So we already have the 3s now, so we can get rid of. No, wait, is this the? No, this is the. Yeah, this is 3s. Yeah. Doesn't. Nope, that's what I did wrong. Go up and that way. I was wondering why I look wrong. Anyway, now we're on the 4s. The 4s are a little different. Okay. The way a 4 works, that one you kind of just have to remember. Again, for each of these, if you're good with your hands, like you can skip count, just go in your head and skip count 4 times. You could also just try to memorize it. 4 times 11 is 44. 4 times 8 is 32. 4 times 20 is 80. That you can use basic multiplication. 4 times 2, the 2 is the tens. 4 times 2, where is the 2? Is 80. And then you put the 0 back at the end, so it equals 80. So if you use that for bigger numbers, if you need be. So I'm just going to cross out. I'm not going to have to write it out. It's just a waste of time. 5s are very easy to skip count by. Think of like you're adding nickels in your head. Like, you easily do division with it. Like 100 divided by 5 is 20. 120 divided by 5 is, well, 24. You can easily count by 5s. So You could easily count by fives on your fingers, like 5, 10, 15, 20. Pretty sure they teach you that stuff in like um, simple grades. So we have the fives done. Now we're on the sevens. The sevens I don't exactly have a trick for. You just gotta memorize those. I have an entire video on this, so this is if I don't really have a trick for it, give me a break. For eights, it's kind of the same way. You just gotta remember. But for nines, it's actually a pretty cool trick. Okay, so what you do is if you have your hands, put your hands out so that your fingers are spread. Okay, once you do that, what I want you to do is if you're doing, for example, let's do 9 times 7. Go from your left hand and count 7 fingers over. So thumb, index, middle finger, ring finger, pinky finger. So you already counted 5 on one hand, and then go on the next hand, pinky, ring finger, and put that ring finger down. Now count the amount of fingers you have on the left side of your ring finger, which should be 6 fingers. And on the right side, you should have 3 fingers. And that's how you get your answer. 9 times 7 is 63. And also, 9 has a really cool trick, or like, thing about it, factor. All of its digits add up to 9. 1 plus 8 is 9, 2 plus 7 is 9, 3 plus 6 is 9, 4 plus 5 is 9, what is it, 5 plus 4 is 9, there's a bunch. 6 plus 3 is 9, 7 plus 2 is 9, 8 plus 1 is 9, and then it ends there. But you can still count 10 fingers. 10 is the highest you can go. 11 and 12 it doesn't go to. But for 10, that's pretty low. Because that's what a lot of you guys have to learn anyway. So that's a cool trick for nines. And for 90, by the way, if you don't see anything on your right side of your hand, it's because it's be, it's because um, there's only tens in that number, not any like other digits like a 1 or a 2. It's just a 0. So that's why it's that, like, that's how it works. Then tens are pretty simple. If you're multiplying it by 22, just put a 0 at the end of 22. If you're multiplying fractions, or I mean decimals, I should say, because decimals are a lot easier to multiply by 10. All you do is you would take the number, for example, 0.2. Make it a little better, I guess. 0.2. Just move the decimal place 1 to the right, and your answer would be, in the end, 2. So 0.2 times 10 is 2. So tens are pretty simple, I'd say. Now we go to 11s. 11s, I'm gonna have to delete all this. But, as I speak, I guess, here, let me just, no, do it, I'm sorry. But, what I'm going to do is this. This is so annoying, I must say. Can I, like, select? Oh, that's so much simpler. I did not know I could do that. Anyway, now, for 11s, there's a cool trick. No matter what the number is, like 3, 6, let's go 36 actually. Because I'll start with the 2 numbers, and then I'll show you the 3 numbers. So, how it works like this is, you take the number 3 and 6, put 3 at the end, 6 here, and then add the digits. 3 plus 6 equals 9. And your answer, 36 times 11, is 396. 36 times 11, 396. That's what we had. So that's how you do it for 2-digit numbers, or anything that really, involves that. But if you have a bigger number, for example, 4, 9, 7, multiplied by 11, multiplied by 11, doesn't work the same way. Yes, if you put the 4 here, but then you add 4 plus 9 is 13. 13, I'll do a different example first, actually. 4, 2, 7 instead, multiplied by, I'll make it a little bigger for you. 4, 2, 7 multiplied by 11 works like this. Now, your traditional method would look like this. 4, 2, 7. I think you guys also go 4, 2, 7, and you just keep an X there like there's a 0. Like a big old 0 there. And you just add 7 plus 0 is 7, 2 plus 7 is 9, 4 plus 2 is 6, and then 4 plus 0 would be 4, and your answer would be 4697. 4697, 4697. Now, there's another way to do it. 4, put a 4 here. 4 plus 2 is 6. 2 plus 7 is 9. And then put a 7 at the end. 4697, that's what we got before. Now, pretty simple, right? But there's also the one that I was trying to show you before. I forgot that there's another way of doing it. 497, let's just say, times 11. Let's start hooking my ones. Anyway. Now what you would do here is 4. A little smaller. 4. 4 plus 9 is 13. Well, you don't put 13 here because that would give you a 5-digit number in the end. So what you would do is you carry over like you do in normal addition. So 13 plus 4. 13 plus 4 is 17. Now if you're trying to put it there, you put the 7 there and that over there. But we're not going to make it 17. Because in the end, 497 multiplied by 11 is 5467. So we just carry it over like this. So we got the 4 here, and then we got 13. So we add the 1 to 4, and turn the 4 to a 5. And then we just leave 3 over here. Now again, now we do 9 plus 7, that's 16. 16 is a carryover again, so 3 plus the 10 is 4. Then we put the 6 down, and then we put the 7 at the end. 5, 4, 6, 7. 5, 4, 6, 7. Now, that's how you do it. That's a cool trick for 11s. So, after that, there's another trick for adding. I guess you could say. It's really for adding, I guess. What I like to do when I add, like 1, 2, 3, 4, I guess, and then 3, 1, 4, 1, I guess. This is like the 4 digits of pi, but this is 1, 2, 3. But when I add, I don't go, 5, 7, 3, 4. I go like this. I add it like it's 2 digits addition. So I go 43, 75, 4375. Let me even check that. 1, 2, 3, 4 plus 4. No, sorry. 3, 1, 4, 2. No, 1. 4, 4, 3, 7, 5. Oh, wait. Did I? Oh, that's why. 4375, and that's how you put it there. Now, if it works like this, the reason I don't do it just like 1 by 1, I have to do it 2 by 2, is because if I have numbers like 4, 6, 7, 8, 9, what you do is you do 4, 6, 10 plus 15 is 25, but, sorry, 10 here, so you have 10 here, then you have 15, add it like this, 15, 115. So I'm going to type it in 4 here. We're going to say 4728 plus 6899. 6899. 11627. Now, like I said, 627. Okay. So what you do, like I said, is you just do the 10 here, 10. 10 plus 15, like this. Make the 10 times that. And then 15, and you get 115. So then once you have 115, put your 115 down. Right there, 115. Then you go over and you're like, oh well, this also is a carryover. So you get rid of 5, turn it to a 6, because 9 plus 2 is 11, so you put the 1 down. Then you go over. Well, this is also a carryover. 17, put the 7 here. I'll probably do this first. Turn the 1 to a 2, and then put the 7 there. 11, 6, 2, 7. 11, 6, 2, 7. So that's how you add. The other way works fine, but I believe that since we read from left to right, it's a lot easier to do math like that. So that's what I would do. I wouldn't exactly do it the other way. Now, what other trick would there be? I could talk to you. Pythagorean theorem. Oh my gosh, goodness. I'm just gonna type it. Pythagorean theorem. Pythagorean theorem. That's how I can spell it at least. Okay. By Pythagoras, I'm pretty sure. Yeah, Pythagoras, yeah. Anyway. Now I'm pretty sure all it works is like a squared plus b squared square equals c squared. Now, it would look like this. Let me write it out for you. What he means is the hypotenuse of a triangle, which is its longest side. This is a horrible triangle, but good enough, I guess. So this would be A. This would be B. This would be C. Then now this side here is the, oh my gosh, I'm gonna suck at spelling this. Hypotenuse. I gotta check my spelling. Hypotenuse. 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 That's how I usually try. That's the hypotenuse. The longest side of a triangle would be that side. This is where the right angle would be. Right angle. And basically a squared plus b squared equals c squared. Now I'm going to look up a squared plus, sorry, did I say equal? Plus, example. Because I'm very bad at this, for example. So if c squared, so that means c is 5. Okay, so 3. Okay, so let's say a here, like they have here, is 3, and b squared is 4, and then c is what? 5. 3 squared equals 6. B squared, or sorry, 4 squared, oh my goodness. 4 squared equals, what did they do actually? 3 squared is 6, plus 4 squared is 8. Okay, so I'm pretty sure what I'm not sure what they mean. I should have done research before doing this, but basically, c squared, a squared, and b squared, adding these two here, adding them would equal c squared, so I should look up how that works. I might do a video on it, just so I can fix that. I'm gonna have to fix that later because, you know, I have to make a video on it because I just don't know. Now, what else is there in math? I think there's twin something conjecture. Twins conjecture or something. Twin prime conjecture, Polignac conjecture. Okay, so what he is saying is the prime numbers. So 2 is a prime number. Is 2 prime? I think is it. Yeah, 2 is the first prime number. 1 is composite. I thought they said. Okay, so 2 is the first composite or prime because 1 and 0 is apparently not either. So 2 is the first. 2 is prime. So I'm going to give you prime numbers. 3 is prime. 5 is also prime. 7 is prime. 11 is prime. 13 is prime. 17 is prime. 19 is prime. 23 is prime. 29, I think, is prime. I could be wrong on that. 31 is prime. And 37. I'll stop there. Prime numbers from 1 to 100. 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 31, 37. Okay, so I did that. 37. So these are like the first, what, 12 prime numbers. So they said that there will never be a case where that there won't be one that differs from 2. So here, this from 2 to 3, you only have to add 1. So this would not be a case of twin, what do you call it? Twin prime conjecture. This would not be a case of a twin prime conjecture. but twin primes. Twin primes. Okay. But 3 to 5 would be, because you have to add 2. So we have this here. 5 to 7 also works. You have to add 2. But 7 to 11 is, well, 9, not 9, 4. I'm not going to swear it actually. This is plus 4, so this would not be 1. But 5 to 7 would be. 11 to 13 is also 1, plus 2. This is plus 4, so this would be plus 4, so plus 2, plus 4 from 19 to 23, then 23 to 29 is 6, so that's not 1, that's not 1. 29 to 31, though, is 2. 30, that's 1, it's 2. This is 6. Weirdly enough, 1, 2, 1, 2, 3, 4, 1, 2, 4, 1, 4, 1, 2. Anyway, 37 to what? 39 after that is 2. That's like a repeating pattern. 2 and 4, 2, 4, 2, 4, 6, 2, 6, 2. There would be a 6, 2 after that. But, it's cool how that works. Basically what twin primes is that, whatever, there will never not be a case of, there would be a difference of 2 between two numbers. So, that's pretty cool, I'd say. What else is there? I guess we could do some more. Can I think of anything? What else is out there that's pretty? Okay, let's do this. Goats. This is the ghost goat. I'll call it that. I think that's maybe like the ghost goat. That's what I'll call it. The ghost goat. Now, you have, no, let's say you have 17 goats. Okay, I'm gonna write it instead. Go, 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 goat. I'm saying goat a lot. Go, go, go. What is that? 8. Go, 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 go. Where we at? 13. Go, 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 and go. So that should be 17. So 12, 5. Yep. Okay. So we have that many. So we have enough. Okay. Now, this is here. There is also going to be 3 brothers, or 3 sons, let's say. Now it goes like this. Son number 1 will, number 1 will get 1/2 of the 17 goats. Number 2 will get 1/3, and number 3 will get 1/9. Now, if you haven't already noticed, 17 is not evenly divisible by 2, 3, or 9. without there being a remainder or not a whole number. Now, if you haven't realized though, you can add an extra goat there. It's a ghost goat though. It's an extra ghost goat. I should fix that G. So there will be an extra goat ghost. It'll be a goat. But anyway, this is the extra ghost goat, which makes 17 plus 1 equal 18. But they only had 17 in the original, but now they have 18 if they add a ghost goat. And if we realize 18 is divisible by 2, is divisible by 3, is divisible by 9. But in the end, there was nothing wrong. Because, let's do this. Let's do it this way. 1/2 of 8, now let me show it to you. 1/2 of 18, which is 18 divided by 2 or multiplied by 1/2, is 9. So we can count these goats. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have like more than half of the goats gone. 9 goats are gone so far. Then we take 1/3 of the goats. 8 divided by 3 or multiplied by 1/3 is 6. Get rid of 6 goats. 1, 2, 3, 4, 5, 6. Now we have 6 goats gone. So 9 plus 6 is 15. Now we have 2 more goats. 1/9 of 18. 8 divided by 9 or 8 multiplied. Sorry, 18. Sorry, 18 divided by 9 or 18 multiplied by 1/9 equals 2. So we get rid of 2 more goats. So we have all the actual goats gone, and now we can get rid of that ghost goat. So in the end, nothing is really wrong with this. So that's also a pretty cool thing, I'd say. See that there. Now, what else could there be? Okay, let's do this one. This one I actually really like. After this, I'll probably do one more, but this will be your spent, and then let's do this side. Spend. This is how much you will spend. Okay. And by the way, you start off balance. That's a horrible. Balance. So balance is basically how much you have left in your account. So if you start with 50 of whatever your currency may be, I will use US dollars. You may have rubles, euros. Um, can't seem to think of anything else. Sorry. If you have any of those kind of things, you could use that. I'm just using the US dollar sign. Anyway, so your balance is 50, but if you spend $20, let's just say, you will have 30 left. Now, if you spend, I don't know, let's say, you spend $6. No, let's say you spend 15 bucks, you'll have 15 left. You spend 9, you'll have 6 left, and if you spend 6, you'll have 0 left. Now, your balance is 0. Now, you spent 50 in the end, but your balance is 51. Excuse me for a moment. Okay, please forgive me, I'm back. But basically, the question is, what's wrong? What is wrong with this chart here? You spend 20, you get 30. Spend 15, you get 15 back. Spend 9, you get 6 back. Spend 6, you get 0. When you add up everything in your spend, you get 50. 20 plus 15, 35. 35 plus 9, 44. 44 plus 6 is 50. But in your balance, 30 plus 15, 45. 45 plus 6 is 51. 51 plus 0 is, well, 51. So what is wrong with this chart? Well, the answer is nothing. Nothing is really wrong with this chart. Because, I don't know, let's say I had way more than this. I can just like this. Imagine I had way more than just 50 bucks. Okay. If I have, I don't know, ooh, that's a little much. Let's say I have $100. So this will be your balance. I'm just going to say BAL. This will be your balance. This will be your spend. Okay, now that we have our little line here, I can go like that, 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 and then we have that. Now let's say I have $100. Now, let's say I spend $1. So 100 minus 1 is 99. Then I have, I spend $5. Now I have $94. Now I spend $50. And now I have $44 left. Then I spend 25. And now I have 19 left. Then I'll just spend, I don't know. I spend 19 again. And then I have 0 left. Now if you add all this, 56, 81, and 100, your spent will equal 100, which is how much you spent, since now you're at 0 for your balance. And it equals 100 in the spent. But if you add it up all over here, 50, 63, 67, what, 147, 217, 220, okay, I really am bad at this, 180, 193, 237, 247, 256. Let me just double check that. 256, 99 plus 94 plus, what is it else? 44 plus 19. Is that what else it says? Is what? Yep, 256. Okay. And your balance would look like you had $256. But you didn't. You obviously did not have 256. The only reason it looks like that is because it's not saying, oh, you spent this much, so you have this much left. It's taking one away. So I can keep taking one away forever. And it would just look like I'm spending a bunch. But nothing's wrong with this, actually. It's just that the numbers that they chose beforehand were perfect. And I mean perfect for it. their number that they chose to spend and all was just enough to make it look like they had spent 50 but had a balance of 51. So that's a pretty cool trick, if you ask me. It's one way to trick people, especially like students. It will get them quite a lot because they're like, well, you never know. It should look like that. So let's do another one. Okay, so let's do the candle one. I like the candle one. Candle one is a favorite of mine. It got me, and it's pretty good though. That's a horrible candle. Flame. So this will be 10 inches. 10 inches. Then you'll have one that's right about. Then you'll have one right here. It's about the same height, so I'm going to make it a little smaller. This one will be 8 inches. Now, it takes, how much time would it take for this candle here to be half of 10? So for example, let's say this is at 3 inches, and this will be 5 inches. I'm sorry, this will be 6 inches. That one will be, so 10 will be 6, 8 will be 3. Obviously that wouldn't work because it would take, let's say it would burn at the same exact rate. Okay, I don't know how long it would take. Let's say, I don't know, maybe an inch an hour. That sound good? Let's go with that. Inch an hour. Um, how long would it take for the 8 inches to be half of 10? Well, the answer is 6 hours. Go back. Hours, 40 minutes. And it's because after that time, this would be at 32, or it would, like, time-wise, this would be at, like, they burn at, like, parts of an inch of an hour. This would be, 3.2 hours left, and that much time, this would have 1 hour and 6 hours left. So, 3.2 divided by 1.6 would equal 2. So that means this is 2 times less than this, which means this is half of that. So that's a pretty cool one again. If you enjoyed this, don't forget to like, comment, and subscribe. If you subscribe, make sure to hit the go check out my podcast. I have a podcast. I haven't been uploading much on there, but I will start doing it more soon. Check out Maxaroni, MAXARONI. I'll be starting to post gaming videos on there, hopefully soon. I haven't been posting recently because I just never really had the time to. But I'll see you guys another time. If you have any suggestions of what I should do, if there's any like mathematical things you want help with, I could start doing those kind of videos like rate, linear equations, just equations, inequalities, graphs, anything like that. So if you need help, just tell me. Bye.